Let's talk about matching. So matching is nothing but it's set of edges which are independent. I will tell you what is example of independent edges. Consider this graph AB, CD and EF. Let's add edge here, edge here. Then in this graph, an edge AB. So I'm writing set of edges. I write only AB. Now I write one more like CD. This AB comma CD are called independent edges. So whenever I say two edges are independent, they should not have a common vertex. Here between AB and CD edges, there is no common vertex, isn't it so? That's why these two are independent edges. Let me add one more EF. So this is called matching. Okay. So one more matching I draw. Just A to B, that's it. So whatever I have taken is independent, right? So one more matching, let's say M3, this is matching M1, this is matching M2, let's write one more matching M3. So I don't take anything. If I don't take any edge, still the whatever I have taken, which is nothing, is independent, right? So what is non-independent I will see, which is not matching I will tell you. Taking AB, this is called empty matching of course. Take AB and BC. This is not a matching because the edges which you have taken is not independent because there is a common vertex to them, right? So that is the concept of matching. This is not a matching. Understand? Let's come to maximal matching. So maximal matching is nothing but it's a matching. We know what is matching, set of independent edges where which is not proper subset of any matching. Okay, that matching should not be proper subset of any other matching. Then that is called maximal matching. Let's try to find out maximal matching. Let's take this example. Let me write a matching AB. So I write in a set form so that easily we can understand. So the set of independent edges, one possibility I am talking about, one is ABCD. The question is this ABCD is maximal matching? Really it's a maximal matching. There should not be a superset which is a matching, but there is a superset which is a matching. You see, I can add, AB, CD, EF. So A, B, C, D, E, F in pictorial representation it will be like this A, B, C, D, E, F. Is it not matching? Yes, it's a matching. Whenever this is a matching, then this cannot be a matching because this is a proper subset of this matching. If some matching is proper subset of another matching, then that cannot be maximal. Okay. Now this A, B, C, D, E, F is maximal matching. Why? That this matching cannot be proper subset of any matching. Okay. So that's why it is maximal matching. How to check whether some matching is maximal or not? Try to add edges to them, and if you can form one more matching, then the previous matching is not maximal. So simple. So that means maximal matching, for maximal matching we can't add further edges. For non-maximal matchings we can add edges always. Okay, let's try. That's why here this is not matching because I can add further edges like EF, right? Now one more example. What about BC? Is it maximal matching? So that means BC is maximal or not. If really it's maximal, you can't add further, right? But I'll try to add. So BC, can I add EF? Yes, we can add EF to it. Still it's matching. So BC is not maximal matching because I can have better matching than that. That means we can add further edges to it. That's why this is, this is not maximal matching, but this is maximal matching. Why? Try to add anything to it, you can't. Let's try to add. Can I add A to B? No, because already B is used by someone. If I use A to B, what happens? If I use A to B, what happens? Degree of B will become 2. Then these two edges will become non-independent, right? So that is a problem. One more landmark you should remember. Whenever a vertex degree is 2 in matching, that cannot be matching. Okay. Now one more. Can I add C to F? Then again degree of C will become 2. So in that way easily we can check. Right. So we can't add further edges. This is about maximal matching. Let's take an example of maximum matching. Consider this graph AB, let's say BC and CD. Okay, in this graph. So maximum matching is nothing but it's a matching whose size is maximum, isn't it? So let's list out all possible matchings. After that we'll find out maximum matching. Okay, so first, empty set, nothing is a matching. Second one, only take AB, that's a matching, because matching is set of independent edges. So I'm taking independent edges AB and CD. So what about only CD? Then write only BC. Then can I add BC and CD together? Impossible, right? Try to write it. BC and CD. What's the problem with this? The problem with this is BC and CD are not independent edges, right? Let me erase it. So these are all possible matchings for this graph. Out of them, this is not maximal because you can add one more edge to it. Example, by adding A comma B to it, I can form one more matching, right? So that's why this is not maximal. I'm cancelling all the matchings which are not maximal. I want to identify maximal matchings. Is it maximal? No, because for AB, by adding CD, still I can form a matching. But the property of maximal matching is, for a matching, if you add an edge, then if it is not, the resultant set is not matching, then only it is matching, right? So here after adding CD, still you are forming a matching, then this is not maximal. But you see here ABCD, you can't add further, that's why it is maximal. Let's mark it. Okay, I write it maximal matching. Now take CD. For that I can add AB and I can form matching, then this cannot be maximal matching. Now what about BC? For BC you can't add any further edges to it, correct? That's why that is a property of maximal matching. Okay, see the definition. It's a matching which is not proper subset of any matching. So this is not a proper subset of any matching. You see, show me if and all if there is any proper subset of proper superset of this one. Understand? So that's why BC is maximal matching. Now come to this ABCD and BC. Out of them, this size is bigger, right? The reason it has two elements. Okay, that's why this is called a matching with maximum size. That's why this is called maximum matching. Okay, so this is about maximum matching. Now one important results about maximal matching and maximum matching we'll see. To become maximum matching, every maximum matching I can say is maximal, definitely maximal. Why? So try to understand this relation. A matching, if it is maximum, definitely it should be maximal. The reason, let's say there is a matching, okay, you want to say that it is maximum matching. Let me denote it by like this, maximum matching, let's say M. Okay, so you have maximum matching but not maximal. What happens, we'll see. If it is not maximal, then what's the property of maximal matching? For maximal matching we cannot add further edges. Let's say this is not maximal, then definitely you can add one extra edge, right? And still we can form matching. If you can do it, let's say that edge name is XY, then I ask one question. Already you said your matching is maximum and you are adding one more edge to it and you are forming better matching than maximum matching, then is it possible? So what's the mistake in this argument is, example, your matching size is 5. Okay, that means there are 5 edges and your claim is it is maximum matching. Then you are saying that it is not maximal. Whenever it is not maximal, then I can add one more edge to it. Whenever I add one more edge to it, still it forms a matching. That is what the property of not maximal matching. Correct or not? For maximal matching you can't add further, but for not maximal matching we can add one more edge and still we can form matching. Let's say if I add it, then I got a 6 size matching. But what was your claim before? You said maximum matching size is 5. Then how can you have size of matching of size 6? You are getting a contradiction. This concept is called contradiction. So why are you getting contradiction? Because you assume that this matching is not maximal. Whenever it is not maximal, we can get contradiction. So that's why, to avoid the contradiction, that not maximal matching should not be possible. That's why the matching should be maximal. That's why from now onwards, whenever a matching is maximum, automatically that should become maximal. Otherwise, I will form a bigger size matching than maximum matching, which is impossible. Understand? So this is a story about matchings like maximal matching, maximum matching, and any matching. Okay.